Okay, we checked all 4 systems and keying with a go.
Space Nuts.
Now, have you visited our website? It's very worthwhile because we spent next to nothing on it and it doesn't really do much. No, I'm not kidding. Well, I am kidding. Spacenutspodcast.com, but we also have an alternative URL, spacenuts.io. I don't know why we did that. I mean, we confuse people enough. Now we're giving them multiple URLs, but it's okay. There's plenty to do there. Of course, we've got our shop. You can visit the shop. You can get quite regular and up-to-date astronomical information through Astronomy Daily. You can leave a review. You can click on our supporter link and find out how to support Space Nuts. There are all sorts of things to see and do. And, we're getting more and more material on there every day. Spacenutspodcast.com if you want to check it out. Now, Fred, we better keep going because we've got another bunch of questions to get through. And this one comes from Abe.
Hey, guys. This is Abe from Boise, Idaho. I love your show. And I had an idea for the Mars trip. Why can't we bring the magnetosphere that protects us on Earth? Can we recreate something like that for the spacecraft using magnets instead of heavy lead shielding or water to protect from the cosmic rays? Thanks. I love your show. I listen to you at work all the time. You guys are awesome.
Thanks, Abe. So great to hear from you and hope all is well in Boise, Idaho. We've talked before about long-haul travel in space, and going to Mars is going to be a big challenge. The exposure to cosmic radiation being one of the many pitfalls of traveling, and protecting astronauts from that kind of exposure. Yeah, he mentioned lead. We've talked about water in the past, but these things are very heavy and difficult to put around a spacecraft, I imagine. So magnetos or magnets, is that a possibility?
It is. It is a possibility. And in fact, Abe is right on the money with his idea, because research has been going on this sort of thing actually since the 1960s. But it's recently taken a big step forward. So back in the 1960s, the idea of magnetic protection from radiation for space travelers, say on their way to Mars, was thrown out because the suggestion was at that time that you'd need to shield a volume of space greater than 100 kilometers across. You'd need to generate a huge magnetic field that stretches out into space 100 kilometers and needs enormous electrical power to maintain it. So that was the old idea, and that's why it was thrown away. But there's recent research which actually come from the UK. It's led by somebody called Ruth Bamford, who's at the Rutherford Laboratory, which is not far from Oxford. It's at Abingdon, if I remember rightly. It used to be one of the sister organisations to the Royal Greenwich Observatory, and I worked there 100 years ago. The Rutherford Laboratory is a high-energy physics laboratory. But Ruth Bamford of this laboratory has recalculated this because, and I'm quoting here from a Physics World article, according to Bamford, these previous calculations are inaccurate because they assume that the solar wind plasma behaves like a normal fluid. Decades of research on nuclear fusion have instead shown that plasmas are subject to all sorts of turbulent behavior not seen in normal fluids, and that furthermore this turbulence can occur on roughly human scales. So the researchers believe it's possible to exploit this knowledge of turbulence to create a much smaller protective bubble, and have confirmed this belief first through computer simulations and then in a laboratory experiment. The latter involved injecting a supersonic plasma into a 1.5 meter long vacuum vessel lined with magnetic coils with a target magnet placed at the far end. And it goes on. This is courtesy of Physics World. So the bottom line is that there is active work going on exactly this topic at the moment. And actually, there was a nice quote. I don't know whether I can find it from Ruth Bamford, which struck me. She made a comment that I thought, oh yeah, here we are. Getting in a tin can with a rocket on your back and flying to Mars is never going to be a safe thing to do. So that's Ruth's comment, and I think that's perfectly true. But what's coming out of this work is the kind of power levels that might be needed to protect the spacecraft, and it's actually quite manageable. They're suggesting somewhere between 1,000 watts or thereabouts and 5 kilowatts. Now that's basically a good-sized electric heater in your living room. Just to put a yardstick on that, the solar panels or the solar arrays from the International Space Station, they generate something like 120 kilowatts. So, if you had that sort of capability, your magnetic protection would be quite feasible. It would be a small drain on that sort of power supply. So, a really interesting question and interesting work that is ongoing as we speak.
There you go, Abe. You're right on the money. Yeah. Right on the money. So, it's obviously, and it sounds like it'd be very cost effective.
It might well be, it may turn out to be something pretty impressive,
Good stuff. Okay, thanks, Abe. Lovely to hear from you. And we'll move now to Brazil.
Hey, hello, Space Nuts. This is Claudio. I'm from Brazil. I have a question about black holes. Oh, no, just kidding. Actually, kind of a black hole humor. No, my question is actually about some episodes ago you were talking about the solar expansion and the fact that in a few million years the sun will be bigger and bigger and bigger, and we will not be that comfortable if we stay where we are now. So probably we would have to change the whole planet a little bit further. So I remembered some time ago I heard this idea of, I don't remember exactly where it was, but we would be capable eventually of changing asteroids' orbits in a way that they could pass on the right side of Earth, and then using the gravity of these asteroids, we could maybe, using little steps, change Earth's orbit so that we could go further and further and further from the sun. Of course, this would take millions of years and probably thousands of asteroids, but it's kind of a nice idea. Maybe we have time, probably. Like the sun's not going to expand that fast. So I would like to know what do you think about this idea? Do you think it's maybe possible in a far future to do these kinds of things? Thank you, and keep the great work.
Thank you, Claudio. Well, great to hear from you too. It's good to have an audience in Brazil. Now, using asteroids to change the orbit of the Earth to keep us moving away from the expanding sun, feasible?
No. Claudio, a great question and a great idea too. But the problem is the raw material that you're equipped with is totally inadequate to do anything to the orbit of the Earth. If you added up all the asteroids in the main asteroid belt, which is by far the biggest congregation of asteroids in the solar system, add their masses all together, what you get is 4% of the mass of the moon, not even 4% of the mass of the Earth. Now, the moon's only an 80th of the mass of the Earth, and you're talking about 44% of that. And actually, a third of that total mass is Ceres, the biggest asteroid, the dwarf planet Ceres. So even if you could grab Ceres and steer it around in the right kind of orbit, it would have effectively zero effect on the Earth. The Earth is much more massive than the whole of the asteroid belt put together. And it's good to have those comparisons. We tend to think we asteroids are quite high on our agenda. We're very conscious of them and we think about them a lot. But we don't often think about their mass in terms of the mass of the planets, but they're basically much, much, much less. So it's not something that could be done. It's hard to know with an object the size of the Earth, even with the most mega scale engineering that you can imagine, it's hard to know how you would shift its orbit artificially. Objects as massive as a planet, they don't move that easily.
There was a really bad, I think it was Japanese or Korean sci-fi that I watched recently, where Earth needed to be moved because something dreadful was going to happen to our solar system, and they had to move us out past Jupiter or something. So they just strapped like tens of thousands of rockets to the Earth.
Yeah, good.
Yeah, that wouldn't work either. I did read a sci-fi novel some years ago called Nemesis, I think it was. I don't know who wrote it. It might have been Robert A. Hyland or something. But
if it's the one I'm thinking of, I can tell you it's Bill Napier, who's a guy I used to work with in Edinburgh. Bill Napier. In fact, it's on these bookshelves, is Nemesis.
Okay. Well, maybe that's the one, but I think the basis of it was that Earth was going to be hit by an asteroid, and they worked out that they could make it miss by using gravity through a spacecraft of some kind to just slowly divert it over time.
That's right.
So your concept does have merit, Claudio, but not on a planet-like scale.
No, that's right.
I think would be fair to say.
That's correct.
All right.
Yeah.
Nice to hear from you. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
Space Nuts. You've been listening to the Space Nuts podcast.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.